Hello, listeners and viewers. Welcome back to the Peggy Smedley Show. We are coming to you live from CES, and this time I have a guest that's been back. We spoke back in November, and it is Michael Moe, who is the CEO, and I think, Michael, are you the founder as well of KULR?
Yes, I'm the co-founder and CEO of KULR Technology.
So I'm excited to have you back. When we were talking in November, we had a great conversation on the radio show, and I wanted all of our listeners, actually this time, and viewers, to get to meet you in person and see you this time. But when we were talking, I thought the discussion we had was amazing. When we were talking about what you guys are doing, I wanted you to come back on the show because we didn't have enough time. We were talking so much that I felt like it was important. I was glad that you were going to be here at CES. And for those listeners or viewers that didn't have a chance to hear that show, tell us a little bit about what you guys are doing now and give like an introduction of the company, because I think it's great, especially all the things you've done with NASA and now you're bringing it to the car space is just amazing. And we're going to show everybody this product because they won't believe it was in space and now it's going to be in cars. So let's talk about it.
Well, great. Thank you, Peggy. Thank you for having me back. So quick introduction about KULR Technology. We are a thermal management company using carbon fiber. I'll show you right here. This is our product right here. You probably can't really see it very clear because it's a very, very black material. These are vertically aligned carbon fiber velvets. They're used for thermal management. We've been doing this for 30 years. I don't look that old, but the technology has been around. Our CTO has been working with NASA, JPL, Boeing, Raytheon for the last 30 years, putting this technology into space applications. So this material that you see here is actually on the International Space Station. We're part of the thermal management solution for the NICER program that was launched into space in May, June timeframe this year. And this material is used for cooling Mars rover batteries, Mercury Messenger batteries. We're part of the Venus Lander project, Comet Return project, and also the satellite around the moon. So this is really space age technology with 30 years of heritage.
We're talking about space age technology and now we're talking about needing it in cars. How far have we come?
Well, here we are. What I show you here is a NVIDIA GPU chip with a traditional heatsink. You put our material, carbon fiber material velvet over here, and then it makes a perfect thermal contact between the chip and the heatsink.
That's just amazing.
And the quality and the key feature of this product is its very high thermal conductivity, withstand high temperature, and it's very soft. So make the whole electronics very compliant, and you don't have to put a lot of pressure to conduct the heat from the chip to the heatsink. As you know, that all the products that we hear in CES, they're getting higher performance, lighter, and more compact. So when you have a more compact, smaller device, the heat becomes a bigger issue, and you don't have a lot of power or mechanical force to put it together. So you want lightweight, flexible, and still take all the heat out. So now,
and yes. I was just going to say, part of the problem when we have that heat is we're having a lot of issues with performance because of the heat, is what we're talking about.
That is correct. So every year you come back to CES, the chip in the car is getting faster. They're going to higher level of autonomous driving. They're packing more density into the battery of the cars. They're having higher resolution, both visual and LiDAR sensors. All these things in a more compact and lighter format generates more heat in a smaller space. So you need higher performance thermal material, lighter, and lower contact pressure to put it all together and still keep the product cool.
Have we thought about this because we all demand more efficiency, more productivity, more speeds, more feeds, and we talk about that. It is we want these smaller chips that we demand to get all these things, and most of us don't understand that LiDAR, that those things that we want in our vehicles to be safer and giving us all these things because we want all this connectivity. We have to do things that require this kind of thing. And in order to do that for the safety side of things, to make sure things aren't catching on fire.
That's right.
Those are the kind of things you have to come up and develop.
That's absolutely correct. So as we go into these higher demand applications, like in a car, previously you have the same technology in your server, in your computers, but your server and computers work in a comfortable room like this 25 degrees C, it's very comfortable. But in the car, you're at 120 degrees F, or in some places close up as 200 degrees F in closed environments. So the temperature range, everything just becomes so much more challenging for the thermal management. And still, like you said, need to be safe, need to be cool, need to be light, and need to react fast. So for autonomous driving, right? So the reaction time needs to be below 100 milliseconds. So you can't slow down the chip because it gets too hot, which typically what they do for smartphones when they get too hot, they slow down the chip. So in a hot environment, you're driving 80 miles an hour down the freeway, and the car's doing autonomous driving, you can't slow down the chip. Because if you slow down, there's a slower reaction, you get into accidents.
And explain how important that is when we talk about it being connected to an infrastructure that we're talking about, because
Yes.
those cars are going to have to communicate with
Yes.
each other, and that reaction time is what's so critical in preventing those those accidents that we talk about.
Yes.
That we are saying that's why we're not going to have those 30,000 deaths that we're saying takes the human factor out that we have today in distracted driving.
That is absolutely correct. So you're talking about an M2M communication, machine-to-machine communication. So both sides of the machine need to communicate the same speed with the same type of performance. So it really increased the demand on the whole infrastructure, both on per device and also the infrastructure to communicate from device to another device. So that's why you see companies here doing supercomputer on wheels and multiple supercomputer on wheels, multiple lasers, so many lasers on the car just to watch out everywhere so you don't back into things. And you got the communication companies like Qualcomm, AT&T, Verizon from the infrastructure side to make sure all that communication in 5G coming up, the gigabit speed in the back end. Now, something you don't see is the optical communication, right? So you have AI, cloud computing, all that stuff. In AI, on the cloud computing side, for the infrastructure, they're getting to 400 gigabit per second for the optical communication. And that is in a form factor that is smaller than this, right? It's 400 gigabit. And for each server or switch, you got 32 or 48 ports in the back. That's hundreds of watts to make sure communication is as fast as you get the data and process the data. So all that presents a tremendous challenge on the thermal management side.
As we talk more about this artificial intelligence that we talk about, and we get further and we talk about this thermal management, are we going to have to look at smaller and smaller in order to be able to do the things that we're trying to connect when we talk about not only just connected cars, but all the things that we want to communicate together? Are we going to have to think about things that are going to be smaller and be able to have this connectivity that we're talking about, and in thermal management to be able to manage that so we don't have this heat?
Yeah, that's exactly right. I mean, you're looking at these geometry of things from the chip node process, right? People talk about the death of Moore's law, so forth. So it's so expensive to reduce the geometry of the chip, so that you gotta find innovative ways to get more processing power, more computing, more communication out of the same small amount of silicon that you have on this, because the cost of reducing the silicon is so high. So that's why companies like SoftBank invest $30 billion to buy ARM, because they believe there will be about 1 trillion IoT devices. Right. So 1 trillion IoT devices all talking to each other. First of all, each one of them want to talk more, and each one of them want to sense more and process more. So each one of them can use space technology to help them cool and being flexible. And then all that signal gets transmitted to the AI, the back end, the cloud computing. That all needs to be processed in real time. And that just creates a tremendous amount of demand on the infrastructure side for thermal management.
Are we getting to a point though that we can't fulfill all that, or are we getting to such a space age way of managing all of this in our connectedness for each device, or that's what it's going to be? It's going to be like the way we manage things in space. I mean,
Right.
really, we're connecting everything to the point that it's the way we're going to get our food. I mean, because in 2050, we're going to have an urbanization problem with crowding and delivering of food. I mean, so we're talking about this being an issue that's going to be something that has to be addressed as well.
I think it would require a kind of a new paradigm of thinking.
Okay.
I think it requires paradigm thinking that thermal management, mechanical integrity, safety of these things is as important a platform choice when you design a new product. So when you design a new product, people think about platforms. So a Qualcomm chip, NVIDIA is a platform. That's what you build your system on. The software from Google, from Facebook, from Microsoft, that's a platform. From Alexa is a platform, right? People talk about Alexa being voice recognition. I think that thermal management, especially these kind of space age thermal management architectures, will be as important a platform for designers going forward to design this 1 trillion connected device universe. Because you need to consider how light it is, how cool it is, how safe it is, at the same time, not afterwards, at the same time when you consider what chip to use, what software to use, and what voice recognition software that you use. It's the same level of importance and complexity going forward.
So do we have to, now let's think about our workforce and trying to educate or go to our schools for what kind of students we want to produce the education that we now have. Because that's a changing of the way what our professors are teaching in school now when we think about this,
Yes.
And I think that's very important what you say, because if that's a new platform thinking, then don't we have to have our schools prepared to get the students who are going to be designing this to be thinking about the way they graduate? Because we have a workforce shortage in a lot of areas right now, and that's part of the problem. We need to be thinking about what type of student comes out to be able to design this kind of future.
Right. So it takes a integrated way of thinking, and like you said, it takes an integrated way of education and training to get to where we are. Like when I went to school 20 some years ago, I studied electrical and computer engineering, but when I studied hardware and software co-design. So it was already a stage where you need to look at the hardware design together with the software design to optimize for it. I think going forward, not only you need to think about the hardware software, you need to integrate that together with the mechanical piece, the thermal piece, more of a holistic approach. An integrated holistic approach. And that's where I think the big data comes in, the simulation, the analysis, the AI part of come in. Part of what we're building now by serving our customers is not only we're providing them the material, providing them a service. So a lot of customers come to us, we look at their problems, we use and utilize the expertise that we have from solving space problems. We apply that to the autonomous driving problem, the battery problem, the IoT problem. And we give our customer a framework to think about how you should think about this. How to plan for this. So where do you put our material? Where do you put our material in respect to your other mechanical structures? How do we integrate with your manufacturing process to lower the cost, to make the whole thing lighter and more rigid without increasing weight? So really to make it cooler, lighter, and safer. And so I think I think for the next, like I said, as a platform play, you integrate with CAD software, system software, chips, our thermal management total solution. Then you can, from the beginning to end of your design process, you can design a really integrated, well-rounded, next generation product.
So we're talking about the way we've gone from CAD to product design to everything now to get people to understand 3D, to what we say, every kind of process in all of this, mechanical engineering, electrical engineering, and we say the way this new design process is, and what we're doing is we have to get every partner involved to think a little differently about the way they bring products to market now.
Right.
And are we doing that right now? Because when I think about it, I think we get so excited, we have an idea, we come to market. We don't necessarily think about whether we've thought about the security. We just have an idea and we bring it to market.
Right.
But are we as an industry, as the Internet of Things, or now we say blockchain, whatever the new buzzword of the day is, are we thinking about how this is going to be embraced and really delivered to market that makes sense, that can be actually the next generation to be able to incorporate and develop a solution that makes sense?
Well, historically, thermal management has been the last problem child, if you will.
Yeah.
So somebody designs something, the software works, it's working, you want to ship it, it got too hot. So you get to a thermal guy, a mechanical guy.
Gosh, it's scary if
Yeah.
something blew up that way. Thermal managed the last thing. Somebody just blew up.
It's
Thanks, we
yeah.
just blew up in space.
Somebody
that makes
blew
me
up,
nervous.
you know,
Yeah.
let's solve the problem. So the guy who's sitting in the
We
corner,
just lost $1 billion, $2 billion, $10 billion rocket. Oh, okay.
you know, but you know, we're gonna ship the product, but it got too hot and delayed for 3 months, 6 months, you might miss that window. So the guy who's in the corner who's solving thermal problems used to be the last guy to call in. And the reason why he got called in is because something went wrong. So he you know, so that was historically what the kind of the design process works. But I think that the most innovative companies and partners that we work with have changed that mindset, you know? So we're looking at from at the beginning of the design, doing the design, and after the, you know, the manufacturing process and the testing process, how does this material and our methodology of working with a partner integrate this whole process? We found the most innovative, the most forward-thinking partners and customers have already begun to embrace that methodology. So we're super encouraged by that. So we established a structure where, you know, our engineering team, who has collectively over 100 years of space thermal technology, that's really literally what we breathe and drink every you know, every day, every week during our Monday meeting. So we look at it like, here's all the customer problems. How do we help and educate this customer from beginning to end to establish a methodology that so everybody can be successful in fast time to market?
So right now we're talking about autonomous vehicles. That's where the big focus is right now.
Very big focus.
We know that that's going to move very rapidly.
Yeah.
You know, faster than we thought. We're moving from level 2 to level 4, and boom, level 5. We're going to be there quicker than we probably imagined.
Yes.
But then we've got to do a lot of infrastructure things that are going to make that happen. What industries do you think are going to have to move just as fast as, you know, connected cars, this autonomous space that we're talking about?
So connected car is probably or what I call the electrification of transportation, is probably the single largest electronics opportunity for the next 10, 15 years. But you could look at all these guys out here, you look at how many cars being sold a year. I think this year, last year they just crossed 90 million cars. I think going to 2025 is probably 100 plus million cars. You're looking at about 20-25% of that being electric, or maybe almost 100% of that, or 50% of that being hybrid and or electric together. So just this year, the thermal management of traditional car is about a $64 billion industry, 64 billion. And then you take that, and the paradigm completely changes between now and 2025 when you move the motor to electric motor, from gas tank to battery, right? So the whole kind of, and then you autonomous driving, the chips, the memories, the SSDs, the communication infrastructure in between, everything changes. So I think that $64 billion in electric vehicle thermal management, a big part of that is going to shift to a new generation of new platform, something like this for thermal management. Then on top of that, you have charging stations, you have communication infrastructures, you probably have lighting systems and smart city infrastructures to support this M2M vehicle
because it
to
can't
vehicle.
happen without it.
Can't happen without it, right? And it actually enhance the experience when you have all that stuff, right? So that is another paradigm shift that comes in. We just talked about 100 million vehicles, that's just cars. Now think about electric motorcycles, electric bikes, anything that moves.
We're going to be talking about buses, trains. We're going to see all that moving in sync at the same time.
Absolutely, right? And that's only things on the land. 2 wheels, 3 wheels, motorcycles, all that. Then you have things in the ocean. So you have boats, ferries, submarines. They're all moving to electrical transportation. Battery powered, electric motor, chips and memories to do the autonomous sensing, all that stuff, and communication. So you have the energy source, the application of energy, which is the motor. Then you have all the electronics around it to control all that stuff. Everything is being electrified.
Do we have the ability to manage all this data properly to be able to do all this electrification that you're talking about? Because I think that's going to be the other big part of this
Right.
that I think is going to be the problem, to be able to handle all of this information.
I think that's communication, right? So we talked about 5G, right? 5G is coming, 2020, moving forward. You have gigabit communication between your car to the infrastructure. So that's gigabit. That's literally, order of magnitude more power than what you have on your iPhone right now, which means order of magnitude more power requirements. And then on the infrastructure side, we talk about 400 gigabit optical links. Then you moving in 10 years, we move to terabit optical links. So all that stuff is just mind-boggling how much data and how much requirement that you're going to have for all this
But you can't have the problem where we have now. We're in this building, we can't get the communication. You can't have that happen with a car.
Yeah.
I mean, you can't have that all of a sudden your car doesn't work and, we're talking about thermal is one thing, but the ability for cars not to work, and we've got some other problems that are going to limit some of the things we want to happen.
So I think that's where we're seeing the customer requirement used to be from, just on the thermal management side, used to be from laptops to smartphones to your gadgets. If your TV doesn't turn on or turn a little bit slower, doesn't matter, right? You just wait for 10 seconds and the TV comes on. But if you're autonomous driving car,
yeah, you can't wait 10 seconds.
You can't for 10 seconds. So we came from space. So where space can't make it in this space. It has to work all the time because it costs too much money. So the discipline, the migration of discipline, and the quality from space, we're taking it down to the car level to meet what the requirement and the mindset from the consumer is. So car safety of that is where our technology and our mindset meet with the
problem is we have a bunch of consumers that think about, I'm just giving you the AI. Our AI, we didn't even think we'd want AI, right? I mean, now all of a sudden we embracing it in our homes. We never thought we'd let Big Brother in. Now we've all got Google Home, we've got Amazon Alexa, we've let them in our homes, pretty much in every room in our house, but a couple rooms, right? We don't, certain rooms we don't want them in. But now we've got expectations of Alexa and or Google, what we expect and how we expect it to understand and learn. That expectation of the consumer is getting more and more higher and higher.
Yeah.
So if we're expecting an autonomous vehicle, the consumer expectation of how that vehicle is going to work is going to be extremely high once they're in that car. And it's just like Tesla now. The consumer expectation is getting higher and higher. Do we think, because AI is proving that our expectations just elevate quicker and quicker. Is there going to be some push-pull, you think, once we're in those vehicles of what we expect? Because who's right and who's wrong when some cars are human in it and some cars are autonomous until we get them all autonomous? What's going to happen on that road? Yeah,
I think that the human expectation is going to be, I think it's going to be tricky at best because, to start out with, because if I expect the AI to drive that car, I expect the AI's reaction time to be faster than human and make better decisions than human. But we all know that in some corner cases, extraordinary cases, that the human reaction will be better than make better judgment and faster judgment than a car, because the human, we're just in here. So that's going to be a kind of a balance. There are things that the car is going to be able to do, maybe just swirl out of a dog coming in, just getting around things faster, but there are going to be things where we're just going to be disappointed. So I think that the professional, that's why I think the NVIDIA does a deal with Uber, get to the professional level first. You do the autonomous shopping cart, you do the autonomous UPS truck first, or the autonomous truck for Walmart first, before you and I just fall asleep and expect something magical to happen with our car, right?
Like what? The consumer and all of us are going to have these amazing expectations. Michael, you and I can continue to keep talking and talking over and over and over. I love this conversation.
Thank you.
But they're telling us we've got to wrap it up. So see that time? They're telling us our time is up, but I've loved it. Hey viewers, listeners, I hope you've enjoyed our day of being here at CES, but we've got to wrap it up. But we are going to be back again tomorrow. Michael, quickly give our listeners your URL so they can go and learn more about what you guys are doing.
Yes, KULR Technology, KULR Technology.com. Thank you very much.
All right. Thank you for being with us. Thank you for watching all of our show today, and we're going to be back again tomorrow, so be with us tomorrow at 10 a.m. here in Las Vegas. Hope you're enjoying what we're doing here live at CES 2018. And always, this is the Peggy, and you can tweet at us, let me say that, at ConnectedWMag or Peggy_Smedley with any questions for any of these great guests. And as always, this is the Peggy Smedley Show, the podcasting voice of IoT and relevant technology. And remember, with great technology comes great responsibility. We'll see you tomorrow.